Hey guys, today we're going to be looking at two-step conversions, which are a little different. But before we get started, the first thing I want to do was to, first of all, encourage you, if you're watching these videos, I encourage you to watch them on actually the YouTube site. I know they're kind of posted and they're sort of embedded on the Google Classroom, but there are two reasons I would advocate watching them on the actual YouTube channel, which I think if you click on like an embedded video, there's a little button that says watch on YouTube, and you can click that and it'll open up in a new tab, I think. Two reasons. Number one, it's bigger, okay? I know that may not seem like a big deal, but I think it does help you focus a little bit more if it's bigger. And number two, more importantly, you can see the comments and you can potentially see cards that I put up. So for example, in that last video over converting, at the assignment chat on Friday, there was a mistake that I made, and some people had pointed out, and I made a correction video, and I put in like on the card like this is wrong, and I made a comment, but I don't think you see that if you don't watch it on the YouTube channel itself, or on YouTube website, I guess. So anyways, today we're going to be looking at two-step conversions. Really, I'm pretty much just going to do a lot of practice, so you have access to this PowerPoint. Okay, I think you can hopefully see that, but I'm supposed to get a second monitor soon, so I won't have to make you stare into the void here much longer, but I gotta just double check to make sure that we're still recording and that I'm actually displaying my screen. Okay, so with what we've done, I want you to think about what's different about the next problem. It says convert 0.000044 megajoules to millijoules. Well, hopefully you've recognized that they both have prefixes, and that's different. Up until this point, when we've done these problems, we've had one will have a prefix and one will just be the base. So this one is slightly different because it's a prefix to a prefix. Now the process is the same, and when you wrote those steps down, hopefully you still have them available. When you wrote those steps down, they're still good for what we're about to do, right? You're still going to do those steps, but we're going to start to engage with those parts that we haven't done yet, because you notice that there's that one step that says, okay, go back to I think it's step 2, but I can't quite remember, or like basically do it again until you have the unit that you want. We haven't had to repeat steps. We kind of just go through one time and we're done. But this is going to be a first example where that's not the case. We're actually going to have to repeat those steps at least a couple times. I'll show you what I mean. So fortunately, this starts out the exact same. There's not a lot that's different really. So we're going to start out the same. We're going to make this into scientific notation. That's going to be 4.4 times 10 to the 1, 2, 3, 4, 5, 6, and of course that's -6. I messed up last time on that scientific notation, so really be careful when you're doing these problems that you do pay attention to the scientific notation, because that negative can mess it up, just like I did on that video last time. Notice we have mega and milli, both start with an M, so how are we going to abbreviate them? And there's also one more, if you remember, there's also micro. We could have microjoules. So how would we abbreviate these and distinguish between them? Now, it's not really that important. You can do it however you want to, but there is sort of a scientific consensus on how to do this, right? For megajoule, for mega prefix, we use capital M, so it would be MJ. Millijoules, we use a lowercase m, MJ. And then what about microjoules? Because there's a capital M and a lowercase m, but there's no other kind of M. So what we do is we actually borrow a Greek letter, and you'll see this later when we talk about friction probably. It's called mu. It looks like that right there. And it's supposed to be kind of like an M, like there's one hump and there's two humps. But I always see it as a U with just a tail on the front. And that's called, that's the Greek letter mu, which is the equivalent of our M. You don't have to know that, but I am going to use those symbols, so I thought that I would at least show you. Okay, so we'll just ignore that. All right, so 4.4 times 10 to the -6 mj over 1 times sign, division sign. I'm going through this a little bit faster because I kind of expect that you know this by now, but let's stop here for just a moment. So I did include those conversion factors still, and hopefully you have them in your notes. When I look up mega, right, it says 1 blank, right? And what does our blank represent? Well, in this problem, it's going to change every time, but in this problem, our base unit is joule. So this relates the prefix to the base. It says 1 megajoule equals 10 to the 6 joules. Right? That's what it says. So I'm going to write that exactly as I said. I'm going to write that right here. I'll write in maybe red. We have 1 megajoule equals 10 to the 6th joules, right? That's the it's not, and be careful, don't put millijoules here because that's not true. 1 megajoule is 10 to the 6th joules. So that's what I'm going to copy down here, right? So 1 goes to the side mega. On the other side is just this thing right here, 10 to the 6th joules. One more time, I'll point out that this thing here is just the number 1 in disguise. Okay. Now, what if I were to stop here? What if I just did the math? What would I get? Well, at least in terms of units, right? What would happen to my unit? Well, megajoule would cancel. So I would have my answer be joules. So if this problem said convert 0.000044 megajoules to joules, we would be done. We could do the math. You would add across the top, get 10 to 0, so you'd actually get like 4.4 as your final answer for number of joules. But we want millijoules. So instead of solving it and then doing another step, well, you could do that. You could solve this and then do the exact same process to go from joules to millijoules. We can just keep going right here. So we can just do another conversion factor. One where, okay, already we know what we want to get rid of, right? You hopefully start to see this pattern. What do you want to get rid of? Put it in the opposite place. Can we go from joules to millijoules? Well, we can, right? And we can go look at that right here, right? Right here is 10 to the 3rd milli. Again, that blank stands for joules equals 1 joule. So I can use that conversion factor. I'll write it again over here. And it said, just doing green. It said 10 to the 3rd millijoules equals 1 joule. So again, we got to put this in the correct order. So we know joule goes on the bottom, and we should be able to tell that 1 goes with joules. So 1 joule. On the other side is 10 to the 3rd millijoules. And again, I'm going to use the standard, just lowercase m and j. Now you'll notice when I multiply, right, I have joules cancel. The only unit I have left is millijoules, and that's what that means when it says, like, if it's the unit you want, you're done, right? Because we have millijoules, and that's what we wanted. So I know that I'm finished, and now I just simply need to do the math to get my answer. So I'm going to multiply. I'm going to see if anything cancels. I don't see anything that cancels, so I'm going to multiply all the way across the top. All the way across the top, I have 4.4 times 10 to the negative 6 times 10 to the 6th times 10 to the 3rd millijoules, and on the bottom is just 1 times 1 times 1. Okay, the bottom doesn't matter. All the units in the bottom canceled. All the numbers are just 1, so really it's not going to matter. We're just going to look at the top. And to find this answer, we simply just use our rules for multiplying powers of 10. We add the exponents. Negative 6 plus 6 is 0, plus 3 is positive 3 millijoules. Okay, and that's my answer. Now, again, I know that may seem like it take a very long time, but once you get this process down, once you kind of know the pattern, it doesn't. You can really do it quite quickly, and that's kind of what we're working towards, getting fast and being able to do this automatically. And really what we're going to be working towards is doing multi-steps, right? This is what I would call a two-step conversion, because you've got to go from one to the next, right? We go from one to the base, and then the base to the other prefix. But tomorrow's lesson, we're actually going to be looking at lots of different units. In fact, I'm going to be making up units to make my point that you can convert with these made-up units. That's another reason why, again, you don't want to just be typing these into Google, because if you do that, you'll probably get the right answer, but you're not going to be able to do that when I make up units, right? Because Google won't know what I made up. All right, let's move on to the next problem. I'll work through this one a little bit faster. Convert 488 million nanograms to grams. Actually, that's just a one step. Yeah, okay. I'm going to make a quick change to this. Instead of nanograms, let's say it was, whoops, I need my brush. Let's say instead of nanograms, what if I was supposed to go to kilograms? All right, so I'm changing the problem. Sorry for the confusion. Hopefully you got that. All right, so first step is always the same. 4.88 times 10 to the 1, 2, 3, 4, 5, 6, positive 8. 7, 8 right there. Over 1, times sign, division sign. Again, I don't want nanograms, put in the bottom. So I do not have, and it exists, but I do not have a conversion factor to go directly from nanograms to kilograms. What I do have is a conversion factor to go from, once again, nanograms, see here, 10 to the 9th nano, and this time the blank is grams, nanograms to grams. So I'm going to write that conversion factor exactly where I had it. So I'm going to write over here exactly like I saw. It said 10 to the 9th nano blank equals 1 blank. And again, for this problem, that blank is the word gram. It's the base unit. Nanograms equals 1 gram. So I see here beside nano goes 10 to the 9th. And once again, don't think, okay, the number 1 always goes on top or bottom, because that's not true. It just depends on where your units are. Focus on the units. That's the dimensional analysis. Focus on the units, and the units will tell you where the numbers go. I know nanogram goes in the bottom, so it will cancel with this up here. So I know that whatever's beside nanogram, 10 to the 9th, will go beside nanogram, regardless of whether it's in the top or if it's in the bottom. All right, so 10 to the 9th nanograms equals on top 1 gram. Now, if I were to stop here, I could cancel these ones. I could cancel nanograms, and I would have grams. But I want, remember I changed it, kilograms. So I'm going to do the exact same step one more time. Time sign, division sign, put the unit I want to cancel in the opposite place. So grams will go on the bottom. And then ask myself, can I go from grams to kilograms? And the answer is yes, I can. So let's look it up. Let's be safe. Don't just think, oh, kilograms 1,000, so put 1,000 right there. You'll get it wrong if you do that. Look up kilogram, right? And what's the number beside kilogram? 1 kilogram. So 1 goes beside kilogram, and 10 to the 3rd grams goes on the other side. So I'm not going to rewrite that. I'm just going to assume you got that. So 1 kilogram, 10 to the 3rd grams. Well, let's see if I'm done. Grams cancel. I don't see anything else to cancel. So I would end up with kilograms, which is the unit I want. So now I just simply need to do the math. I'll do it down here. So it's going to be 4.88 times 10 to the 8th times 1 kilogram. On the bottom is just, I remember I canceled those ones, so not that big a deal, but I did do it, times 10 to the 3rd. So that's 4.88. Once again, the only unit I have left is kilograms, which is exactly what I wanted. Kilograms over, on the bottom, 10 to the 12th. And then the last step, when we divide powers 2 and we subtract. So 4.88 times 10 to the 8 minus 12 is negative 4. And that's my final answer. Okay, I'm going to skip that one again. Okay, here's another one, kilograms to micrograms. So I'm probably going to do one more, and again, I'm going to go quick. I'll go faster every time. This is a video, obviously, so you can stop it, you can rewind it, you can try it on your own. I'll do one more, and then I'll have you do one on your own, and I'll show you the solution. Sorry. Okay. So once again, I'm going to put this in scientific notation. It's 8.8 times 10 to the negative 1, 2, 3, 4 kilograms. Okay. I want to get rid of, see, I automatically just start writing it, right? I just automatically put kilogram in the bottom because I know that I want to cancel it. I'm going to go from kilograms to, again, I'm going to the base unit. So I'm going to go from kilograms to grams. And again, that's what you have when you look it up right here. It says 1 kilo, again, the blank in this problem is gram, equals 10 to the 3rd grams. So that's 1 kilogram is 10 to the 3rd grams. Let's see what cancels. Kilogram, that's it. So I have grams, but I want micrograms. So I'm going to do another conversion Another step. Again, I automatically know I don't want that, so I'll put it in the bottom. Grams in the bottom. I'm going to grams to, now remember I showed you that symbol earlier, mu, micrograms. You don't have to use it, doesn't matter, but I am using it. I just want to know where it came from. So then I look it up, and let's see, micrograms. So on this one, it says there are 10 to the 6th micro equals 1 gram. So 10 to the 6th goes beside micro, regardless of if it's in the top and bottom. Okay, it's in the top, so 10 to the 6th goes on top, and 1 goes on the other side. Let's cancel again. We got grams canceled, and I think that's it. So I know I'm done. I'm done setting up because I have the unit I want. So on top I have, when I multiply across, 8.8 times 10 to the -4th times 10 to the 3rd times 10 to the 6th micrograms. On the bottom is just 1 times 1 times 1. So bottom's not going to matter again, it's just going to be 1. So on top I get 8.8 times 10. We're going to add -4 plus 3 is -1 plus 6 is +5. My unit is micrograms. So there's the answer. All right. I'm going to show you one more, but here's what I would like for you to do. Okay, I want you to let me pull up. I think the last one. Yeah, let's do this one. So what I want you to do is I want you to pause the video. Right, I'm not giving you a lot of problems today. I'm not giving you any problems today. Right, the idea is that this video is a little long. You're going to take time to watch the video. You're going to take time to practice, and this is part of your assignment. Right, it's not one I'm taking up, but it is your assignment. You are going to pause the video right now, and I want you to try to do this problem on your own. Okay, try to do it, see what you get, and then watch what I do and see where, if you messed up, see where you messed up. That's going to be important. Right? If you just watch this through and you don't try this, you're missing out on practice, and that's not good. Okay, so hopefully you paused. You already answered it. I'm about to go over the answer now. Oops, I gotta select the brush though. All right, so first step, of course, it's just 8. I can put 8.0, but really no need. 1, 2, 3, -3 kW over 1 times sign. And I'm just going to go through this quickly. I want to cancel kW, put it down there. I'm going to go from kilowatts to watts. 1 kilowatt is 10 to the 3rd watts. Cancels. I got to keep going though, right? Because I want gigawatts. So I'm going to go from watts to gigawatts. 1 gigawatt is 10 to the 9th. Cancels. Cancel 1 if you feel like it. Doesn't really matter. Okay, so on top I have 8 times 10 to -3rd times 10 to the 3rd times gigawatt. On the bottom I have 1 times 10 to the 9th. So on top, that's 8 times 10 to the 0. We add similar exponents. -3 plus 3 is 0 gigawatts. On the bottom is just 10 to the 9th. So when we divide powers of 10, we subtract the exponents. So my final answer is going to be 8 times 10 to 0 minus 9 is -9 gigawatts. That's my final answer. So I hope you got that. If you didn't, figure out where you went wrong. If you can't figure out where you went wrong, send me an email. Okay, ask me in one of our Google Meets. Come to the Google Meet. When we have our scheduled Google Meets, I'll be there, ready to answer questions. I can show you how to do that, no problem. If you work down paper, you can even show me your paper, and I can probably point out exactly where you messed up. That's our answer. Okay, just so you have more practice. You can stop the video here if you feel comfortable. I'll do one more again, just so you have more examples to look at, if that's helpful for you. And I'm just going to I'm going to do this at like the pace I would actually do it. And you can see, now I'll point out that I'm using a little like digital writing pad, which is actually kind of, I don't know, love using it. So I'm actually a little bit slower than I would normally be. Just to watts, it's 10 to the 3rd milliwatts in 1 watt. Cancels. Actually, look, 10 to the 3rd can cancel. Go for it. If it's the same top and bottom, you can cancel. And watts to megawatts. I know 1 megawatt is 10 to the 6th watts. So watts cancel. That's it. So on top, I'm just left with 9.74 times 1 megawatt. On the bottom, I just have 10 to the 6. Now, you may be kind of wondering about this. I can rewrite this, right? There's two ways you can interpret this. Either you can interpret this as 9.74 times 10 to the 0, and then, 0, I know it looked like a 6, divided by 10 to the 6, which obviously 0 minus 6 is negative 6, 9.74 times 10 to the negative 6th. Sorry, I'm running out of space. Or you could just say, hey, why don't I move this to the top? Remember, if you have a power in the bottom, it becomes negative in the top, and vice versa. If you have a power in the top, it becomes negative in the bottom. So I could just move, if I move 10 to the 6th up top, it becomes 10 to the negative 6th, and it's 10 to the negative 6th megawatts. Oops, I forgot my unit there. Either way, you get the same answer. It should be 9.74 times 10 to the negative 6. Okay. So I'm going to end the video there. Again, a little longer, so there is no definite assignment today. It's just watch this video, just practice. Tomorrow there will be some practice problems for you to do. Okay, I'm trying to be reasonable. Please let me know if you think I'm asking you to do too much. I'm trying to not ask you. I'm trying to keep what you do per day to 30 minutes or less. So it looks like this video is going to be about 22 minutes. So again, if you take 22 minutes and you practice that problem, you try to work out problems on your own for an extra 2 or 3 minutes, then we should be there. So, and then tomorrow you'll have an assignment. Now, if you just want to work ahead, you can, and while it's fresh, you can just go ahead and start working on it. But technically, the assignment will be the next day. We'll count for that. So please ask. I know some of this is getting weird, or more abstract, I should say. And so please ask if you have questions or need help with it. Please email me. Or come to one of the Google Meets that we have scheduled for our class. All right. Thanks for watching.